Hello everyone, welcome to a new video where I want to follow up on my last week's video where I showed you how to run your Azure Container DevOps agents inside a Kubernetes cluster. Today I want to show you how to run the agent with Azure Container Apps. Before I tell you about this, let's have a quick recap of last week's video. There I told you that with Azure DevOps we have several options how to run our agents. The first one would be to use Microsoft hosted agents. There we have Ubuntu or Windows agents, and they're great because Microsoft takes care of everything. The downside is that it comes with some limitations. For example, we can't inject the agent in our own VNet, and therefore we might have to run self-hosted agents. And there we have several options. For example, we can run them on virtual machines. That's a good solution. The downside is that we have to take care of the VM. This means we have to install updates, install the agent, all the software we need, and it might be expensive if we run it 24/7. Then last week, I showed you how to put the agent inside a container and let the container run in Kubernetes. And today I want to show you an alternative to this where we use Azure Container Apps, which might be a better and easier solution. And next week, I want to talk about managed DevOps pools. That's a new solution and might be the best option we have right now. So the plan for today is we are going to configure the Azure DevOps Server so we can run our own agent. Then we're going to test the agent locally. If this works, we're going to deploy it to Azure Container Apps. Then we're going to configure KEDA, the Kubernetes event-driven architecture, and this will allow us to scale our agents based on the pipelines. So for example, if no pipeline is running, we don't have any container running, and therefore we also don't pay anything. And if we start a pipeline, then KEDA will start as many agents as the pipeline needs to be executed. And lastly, I'm going to show you how to attach a storage volume to your container that's running in the container apps. And with this, let's get going. So we are here in Azure DevOps. And the first thing we are going to do is create a personal access token. So if you go on the top right and click personal access tokens, then we can again click on the top right and say new token. Then we provide a name, for example, agent token. We can configure how long it should be valid and then the scope. And as scope, we have to use agent pools and we provide the read and manage permission. And then we create this token. And now it's very important that you copy this token because this is the only time that you can see it. If you don't save this token, you have to create a new one. So I'm going to store it on my second screen. And this token is going to be used by the Azure DevOps agent to authenticate against the server. And the second thing we have to configure is the agent pool we want to use for our new agent. So if you go to our project, then on the left to the project settings, and we select agent pools. There we can see we already have two Microsoft created pools and we are going to create a new pool. So we click add pool, say a new pool for self-hosted. We provide a name. There you can provide any name you want, and then we give it permissions to all the pipelines so we don't run into any problems when we test it. And we create this pool. And that's already everything we have to do. And now we can already test our agent. So let's move to the command line. And I've already prepared the command for Docker to run the Docker image we created in the last video. So what we're going to do is use Docker run, and then we provide a couple environment variables. So the first variable is the URL to the Azure DevOps Server. Then we provide the access token we just created. Then we provide any name for the agent. There you can select whatever you want. And lastly, we provide the name of the agent pool we just created. And then I'm going to use the image I created in the last video. So if you just want to try out if your configuration worked, you can also use the image, or you can go back to the last video and there you can see how I created this image. So let's start this. This is going to take a couple seconds until the agent is started, downloaded and configured. And in the meantime, we're going to our Azure DevOps Server, and they have already prepared a pipeline so we can test the execution. So if you take a look at the pipeline, what's important here is that you use the same pool name we previously created. And there you can see I have a bash script that's executing an empty script. So it's not going to do anything. It's just testing if the agent is picking up the pipeline and if the pipeline is executed. So let's have a look if the agent is already running. This might take a couple seconds longer until everything is downloaded. So I will stop the video here and I'll come back once the agent is running. The agent is started, and as we scroll down here, you can also see what's happening. So it's connecting to the server, it's registering the agent, and right now it's listening for jobs. So if you execute the pipeline now, everything should work. So let's test this. We run this pipeline, and then it should only take a couple seconds for the agent to pick up the pipeline and execute it. So the pipeline execution is started. And if you take a look at the output, we can also see here in the agent, it's running the job named script. So the pipeline worked, everything is green, and the agent now will automatically shut down and everything is great. And with this, we can start to deploy it to our Azure Container Apps. So let's clear this. And I will provide all the files for you in the description with a GitHub link. And first on, we're going to configure a whole bunch of variables. As you can see, I already tried to add comments everywhere where you have to change something. For example, I'm in Canada, therefore I'm using Canada Central as my location. If you're somewhere else, pick a location that's close to you. Then we also use the token, the personal access token we just created, the agent pool name, the URL to the DevOps server. And the last thing you also have to change if you want to follow along is this variable. At the end, we're going to use a storage account, and a storage account name has to be unique worldwide. So since I'm already using this name, you have to use a different name. And with all this variable created, let's create a new resource group. Actually, let's clean up this quickly. Let's create a new resource group. So with the name of the variable we just created and the location in Canada Central. This should only take a second. And then inside this resource group, we're going to create a container app environment. For this environment, we provide a name and then again the resource group and the location. And if we simplify here a bit, what this environment does is it puts all the containers inside a box. And the containers inside the box can communicate with each other. And this environment also takes care how the outside can access these containers. Since we don't need to access the container, we'll just have this box and then our agent running inside this box. So this might take 1 or 2 minutes, and I will continue once the environment is created. The container app environment has been created, and now we can create the container app inside this environment. So let's clean up the window and copy the command. So while this is running, let's take a look what we're going to do here. So we use the Azure CLI again. Then we provide a name for our container, the resource group and environment we used before. Then we tell it what image we want to use. That's the same image we used when we tested the agent locally. Then CPU and memory. This is the lowest you can use. So a quarter of a CPU core and 500 megabyte of RAM. Then we provide the personal access token and the organization URL of the Azure DevOps Server as a secret. And then we reference the secret in the environment variables and also provide the name of the agent pool. And lastly, we configure the trigger. So we say this one is manual. I will talk about it later, but this is a limitation of Azure DevOps, and we also want to test if the implementation is working. So we're going to start it manually, and we always have a maximum of 1 jobs running. And this job is now created, and now we can start it. So we just say container app job start, and then we provide the name we just gave it and the resource group. It should only take a second. And to make sure everything is working as expected, we can check the start time or the status of the agent job. So if we execute this command, we will see the status is running and the start time was a couple seconds ago. And with this in place, we can go back to our pipeline, execute the pipeline again, and then the new agent should pick it up. So if you're going back to Azure DevOps and run the pipeline again. So again, this pipeline is not doing anything except executing an empty bash script. So it should only take a couple seconds to execute. And we can already see the agent picked it up. And since we only have this one agent running in the container apps, we know it's the right agent. So now it's running the script and it should finish the pipeline. And everything worked as expected or hoped. And with this in place, we can go back to our agent pool. So we go to the project settings, then we select agent pools. Then we go inside the agent pool we previously created. And then we select agents. And there we can see one agent and the status is offline. So this one agent is the agent we created before, and it's offline because the Azure DevOps agent waits to execute a pipeline, and after the pipeline is executed, it will shut down. But as I said before, Azure DevOps has a limitation, and that's why we created this agent. And the reason why we need this agent is Azure DevOps needs at least one agent inside an agent pool to be able to use this agent pool to schedule pipelines. So we have to restart our agent job. So if you go back to the terminal and we use the container app job start command again. And then we are going to wait a couple seconds until the agent is running. So if you refresh this page, then the agent should appear there in a couple seconds. So the agent has appeared. We can see it's online. And something I just said was wrong. The agent we see here is an old agent because our agent is called placeholder agent, and so it was automatically cleaned up. And now we can see it's online, and now we can disable it. We're also going to disable the old one just to be sure. And the reason why we disable it is, as I just said, Azure DevOps needs at least one agent inside the pool to be able to use this agent pool. And we're going to install KEDA, and we use KEDA to scale our agents only when we need them. And to do this, let's go back to the terminal. And there we create a new container app job. So let's paste this here. So the command line doesn't let me scroll up for whatever reason, but the only thing we are missing is the name. Then we have the resource group and the environment we created before. Then this time we set the trigger as event because we want to trigger our container app when something happens with the Azure DevOps pipeline. Then we can give it a timeout. So this depends how long your jobs should be able to run. And we configure the completion count as 1. This means we only need one job or one container to finish to have the task finished. Then we provide the same container image as before. Then here we say we want a minimum of 0 container running. This allows us to have no container running and then only start them when we need them. Therefore, we don't have to pay when they're not running. Then we set a maximum of 10 container. This should be set as high as you have licenses. We will see later, I have 2 licenses for my Azure DevOps Server. Therefore, I'm able to run 2 jobs at the same time, even if I start more agents. Then the polling interval, how often or in what interval KEDA is checking the pipeline. So in this case, KEDA checks every 30 seconds if there's a pipeline running. Then we just provide a name for the scaling. Then what type? Here we use Azure DevOps, Azure pipelines, because we want to scale based on our Azure pipelines. Then we provide the same information as before. For example, the pool, the access token, the URL to our Azure DevOps Server. And this time I give it more resources, specifically 2 CPU cores and 4 GB of RAM. And the container job already has been published or deployed. And with this, we can go back and test it. So if we go back to our pipeline and we refresh our agent pool, we see still no agent running because they will only start when we need them. So if you go to our pipelines, and there I have a second pipeline. So let's start this pipeline and then take a look what this pipeline is doing. So as you can see, we have 5 jobs. And if you take a look at the pipeline, it's very simple. So we have 5 jobs and all the jobs do is sleep for 5 minutes. This is just to simulate a job that's running for a couple minutes. And now we expect KEDA to see that there are 5 jobs. Therefore, it will start 5 agents. And if we take a look at the execution, then it might take up to 30 seconds because KEDA is checking every 30 seconds. And then it might take a couple seconds to start the container and to start the execution. And then the jobs should be running. And there we can see we have 2 jobs running, job number 1 and job number 4. And if we go to our agent pool, I expect there to see 5 agents. And there we can see we have 5 online agents, but only 2 are running right now. And this is what I said before. This is another limitation of Azure DevOps because I only have 2 licenses to run 2 parallel jobs. Therefore, I'm only able to execute 2 jobs at the same time, no matter how many agents I have. So right now I have these 3 idle agents running. I'm paying for them, but they don't do anything. Therefore, configure your scaling based on the licenses you have. And now if you wait a couple minutes, the pipeline will finish executing. It should run successfully since it's not doing anything. And then the agents will shut down and I don't pay for them anymore. After some wait time, we can see all 5 jobs have been successfully executed. And if we go to our agent pools now, then we only see the agent we used to test locally. This agent is offline because our Docker container is not running anymore. And then the placeholder agent we created before. But none of the running agents are there. That's because Azure DevOps automatically cleans them up. And one downside of this approach is that you always have this one agent running. And the agent might time out and then you don't have any agent running. And if the agent is running, you also pay for it since the container is running. So a potential solution, or kind of not nice but working workaround, would be to delete this one. And then you only have this one offline agent and just keep this offline agent forever in there. It's not going to do anything, but it allows you to scale automatically with KEDA. And you also don't pay anything for the agents while they are not running. So to recap, what we did so far is we configured Azure DevOps to run our own agent. Then we tested this agent in a Docker container locally. Then we deployed a placeholder agent in Azure Container Apps and tested it. And after this worked, we configured KEDA, the Kubernetes event-driven architecture, to scale automatically based on the pipeline. So if we start a pipeline, KEDA sees this and starts as many agents as the pipeline needs to execute every job. The downside of this approach is that KEDA starts as many containers as the pipeline needs and doesn't regard the licenses you have for Azure DevOps. So we have seen I have 2 licenses, but KEDA started 5 agents and therefore I paid for idle agents or idle containers. As I said before, configure KEDA to start only as many agents as you have licenses and have one offline agent inside your agent pool so you can use KEDA to schedule new pods or a container in this case. So the last thing I want to show you is how to attach a storage volume to your container app. And the reason I want to show you is I needed this last week. And the documentation of Microsoft is not the best. So it works, but the recommendation is to do everything by hand. And I want to show you a more automated approach. So let's go back to our terminal. And first up, we're going to create a new storage account. So that's an Azure storage account. We provide the same resource group as before. We provide a name, the same location, and then the type. So it's a storage v2 account, and we use local redundancy, which is the cheapest option. And that's good enough to test the access. So it should only take a couple seconds. And after we have the storage account, we're going to create a file share. So let's paste this in. And again, we provide a resource group, then the storage account name we just created, then a name for the file share, a quota. So we allow a maximum of 32 GB. We enable SMB and we format the output as a table. So it should be nicely readable. Then we execute this. And then we can see our file share has been created. And the last step we have to take is get the storage account key so we can use it to authenticate our container app to the storage account. And let's paste the command. And what we do is we use the AC storage account key list command. We provide the name of the storage account we just created. And then we query the first key value. And we save it in a variable. So let's do this. And just to check everything worked, we can see here the key. And now we can attach this storage account to the container app environment. Let's paste the command for this. And as before, we're using the environment name, in what resource group it's located, then the access mode. In this case, we want to read and write. Then we provide the name to the storage account, the key we just collected from the storage account, the share name and the mount name. And then again, we have the output as a table. Let's execute this. And it has been added to the container app environment. And now we can attach the volume to our container app job or container app in general that's inside this environment. And this is where it gets a bit complicated. So let's have a look at what Microsoft recommends, and then I can show you how to automate it a bit more, or at least make it easier. And the way the documentation recommends is use the AC Container App job show command. Then you provide the job name, the resource group, and then you store it in a YAML file. In this case, I named the file deployed container app. Let's execute the command and then open the deployed container app file. So here you can see the file, and it contains everything that's configured inside the container app. So you can see the location, the name, our agent pool name, and all the way down we have here the volumes. And what the Microsoft documentation recommends is that you delete these volumes and then you add your own volumes, but you also have to add it inside the container and then manually upload it again. So for example, if you create a new container app, the idea of the documentation is you create it, download the file by hand, update it, and then upload the file again. It works, but it's not a good approach. So a better approach would be to have all the configuration already in a file and then just upload the file when you create the app or when you update the app. And this file already has all the volumes, all the configuration. And I've prepared here a file, and this file is also in the shared folder. In the GitHub repository. And as I said, here you have all the configuration of the container app. So if you want to run this file yourself, you have to update, for example, the ID of your subscription. And if you didn't follow along with my naming, you also have to update, for example, the resource group or the location. And then if you scroll down, you also have to update, obviously, your personal access token and the URL to your Azure DevOps Server. And the part we're looking for is this volume mounts. So we've added here a volume mount, and we've also added the volume. So here the volume, we use the same name for the storage account we used before, and we mount it under the shared path. And with this, we can use the volume inside our Azure DevOps pipeline. The last step we have to do is we have to upload this file and update our container app with this. So let's go back to our command line. And now we use the AC Container App job update command. We again provide the name resource group, and this time we provide a YAML file. So that's the YAML file I just showed you, which contains the volume mount and the volume. And then we upload this, and the volume should be attached to our container app. And the great thing about these files is once you have them, you can use them to create new container apps. The only difference is that you would use here the AC container job create command, and then you provide the YAML file, and you don't have to provide any other configuration variables because they're all going to be overwritten from this YAML file. And this allows you to have the deployment fully automated, and you can also override values with your Azure DevOps pipelines. So now the container app has been updated, and we can test if the share is actually working. So let's go back to our Azure DevOps Server. Then we go to our pipelines. And I've also a pipeline prepared for the file share. So let's start this pipeline, and then we're going to take a look what this pipeline does. So this pipeline again is very simple. It executes a bash script, and this bash script creates a new file called sample.txt in the shared folder or share folder. So that's the network share or the storage account we have created before. So let's wait until the pipeline is executed. Should only take a couple seconds, and then hopefully we see the file in our storage account. So I'm going to stop the video, and I will be back once the pipeline has been executed. The pipeline has been executed successfully, and now we can check if the file is actually in the storage account. So we go to the Azure portal. This is the resource group I've created in the beginning and we've used. So let's refresh this, and then we should see the storage account. And if we go inside the storage account, we have the storage browser, and there we can see our file shares. So we have the file share we created before, and there we should see our file. Exactly. Here you can see our sample.txt file. So our Azure DevOps pipeline has created this file in the volume of the container app. Great, everything worked as expected. Now let's look at some considerations when to use Azure Container Apps to run your Azure DevOps agents and when you shouldn't use them. I think the best use case of Azure DevOps agents inside Azure Container Apps is when you have small deployments and you have to be in the same VNet as your Azure resources. An example could be you have a private Azure Key Vault or a private container registry, and you want to push a container into the registry or update a secret in the Azure Key Vault. Then running Azure Container App is great because you start it when you need it. You don't need much of the resources. And once you're done, you just stop the agent and you don't pay for it anymore. I just said this, you only pay for it when you're running the container app. So if you compare to Azure VMs, where you pay for it whenever they are running, and usually they run throughout the day, at least during the workday, but often 24/7, and therefore they might be way more expensive. Plus you also have to take care of them, like install operating system updates, keep your software up to date. And with the container apps, you just update your Azure DevOps agent container and publish a new version, and it should be working. A problem with this approach is if you want to do Docker in Docker. For example, it is not possible that your agent inside the container apps builds a Docker file. In my last video, I showed you a workaround in Kubernetes how to do this. But to do this, you needed the privileged mode, and this mode is not available in the container app because of security concerns. So if this is your use case, then container apps probably not the right solution for you. And I also said this in the video, take a look at the licenses you have for parallel builds and only scale your agents to the maximum amount of licenses you have. Otherwise, you have more agents running than licenses, and the agents will be idle and you pay for them and they're not doing anything. Lastly, we have a more general approach to Azure DevOps agents inside a Docker container, and this is when you want to test it locally. You can put the agent in a container or just download an existing container, run your tests, and then stop the container. And your system is clean as it never ran an agent before. And with this, we come to an end for this video. Next week, I'm going to show you how to use Azure DevOps Managed Pools, which might be the best option we have right now to use self-hosted agents. And if you like this video, please like it, share it, give me some comments what you would like to improve, other topics you would like to see, and I see you next week.